Today we'll be learning about Dalton's atomic theory. According to Dalton's atomic theory, any matter, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. All matter is made of very tiny particles called atoms which participate in chemical reactions. Atoms are indivisible particles which cannot be created or destroyed by a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of whole numbers to form compounds. Small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. So these were the postulates stated by Dalton, but most of these postulates have been proved wrong. So we'll be doing the limitations of Dalton atomic theory too. Limitations or drawbacks, whatever you call them. Okay, so the first limitation is atom is no longer considered as the smallest indivisible particles. This is because recent studies have shown that atom is made of still smaller particles called electrons, protons, and neutrons. So it can be further divided. So as the atom can further be divided into neutrons, electrons, and protons, we do not consider it as the smallest indivisible particle. The next limitation is atoms of the same element may have different masses. For example, there are two types of atoms of chlorine with masses 35 and 37. On the atomic scale called mass numbers discussed later, such atoms of the same element with different masses are called isotopes. So isotopes have been further discussed in the 4th chapter, Structure of the Atom. Isotopes are basically atoms of the same element which have the same atomic number, but the mass number is different for these. And for example, we can say chlorine. The two isotopes of chlorine are chlorine 35 and chlorine 37. So both have the atomic number 17, but one has the mass number 35 and the other has 37. Atoms of different elements may have same masses. For example, atoms of potassium and calcium are known with same mass number 40. Such atoms of different elements with same mass numbers are called isobars. So this is kind of the opposite of the last point, that isobars are atoms which are of different elements and have different atomic numbers but have the same mass numbers. And we can give the example of potassium and calcium isobar, which have the same mass number 40. Substances made up of the same kind of atoms may have different properties. For example, charcoal, graphite, and diamond are all made of diamond atoms but have different physical properties. For example, graphite is actually a substance that we can break. We have graphite in the lead of the pencil and we can break that. And diamond is known as the hardest known substance. So that is one property, and diamond is very shiny and graphite is very dull. So they have different physical properties. Fifth, the ratio in which the different atoms combine to form compounds may be fixed or integral but may not be simple. For example, sugar molecule, which is C12H22O11, contains C, H, and O in the ratio 12:22 and 11, 12:22:11, which is integral and fixed but not simple. The modifications as given above are called the postulates of modern atomic theory. So this was it for today's video. Hope you learned something. Bye.